All right, so we're going to talk about factoring polynomials. So the very first thing that we learn, the very first thing that you have to understand is how to look at a polynomial, look at the terms, and see if all of the terms have something in common. See if there is a common factor or a greatest common factor that we can divide out of this. So for example, if we were looking at 8x squared minus 80x, we would look at those two terms and say, can we divide, do they both have something in common, right? Both of those could be divided by 8, right? They both could be divided by 8, and both of them also have an x. So they could both be divided by one of these x's because they both have at least one x, right? So the greatest common factor of this polynomial would be 8x. So the way that we would factor it is we would divide both of those by 8x, and we would go ahead and write the greatest common factor on the outside, and then inside the parentheses we would write the results of dividing each term by 8x. So if I took 8x squared and divided that by 8x, my result would be 1x, right? This would be 1x, or just x. Minus, and then if I took 80x and I divide that by 8x, well, 80 divided by 8 is 10, right? And x divided by x is 1. So this would just become minus 10. And so this would be factored form by pulling out an 8x. We could write it as 8x times x minus 10. All right, so let's try another one. We have another polynomial. In this case, we have a trinomial. We have 3 terms, and we want to factor out the greatest common factor. Before we try to do any other factoring, what do they all have in common? Right? So we have 3 terms, and all 3 terms, okay, what can we divide out of those 3 terms? Well, each one of those terms we could divide by 2, right? We could pull out a 2, divide a 2 from those, and then they each have w in them as a variable part. So we can pull out 1 w there, because over here we can divide this one by w. It only has 1, so we can at least divide that one out. And the rest of these have, we have w cubed and w to the 4th there. So definitely we can pull out one of those w's as well. So the GCF of this one would be 2 and a w, and we could write this as 2w and rewrite our polynomial by dividing 2w into each term. So 6w to the 4th, let me write that out here. 6w to the 4th, divide that by 2w. That would be 3w cubed. 3w cubed. You would subtract these exponents, 4 minus 1, and essentially one of those would just divide into each other, right? W divided by w is 1, so you get w cubed, okay? And then we'd keep going. We would say minus, now we have 10w cubed. We'll divide that by 2w, right? That would be 5w squared, right? 5w squared. And then last but not least, I have that 2w. And of course, if I divide that by 2w, I would just get 1. So this would be factored form just by pulling out that greatest common factor. This is what the result would be. Let's try one more. Let's factor out the GCF. So I have 35a squared b squared minus 5ab. So I'm just trying to find what common factors I can divide out of both of these things at the same time. So between 35 and 5, they both can be divided by 5, right? And then if we look at the variable parts, right, they both have at least one a, and they both have at least a b. So the GCF here would be 5ab. So the way that I would write that is 5ab, and then outside of the parentheses and inside, I would write the result of dividing each of those terms by 5ab. So this first one here, if I take 35a squared b squared divided by 5ab, that would be 7, and this would be AB. Again, because essentially if I multiply those together, right, 5AB times 7AB, hey, I'm getting the 35A squared B squared. Okay, that's another way to kind of cross-check if this is correct. And then if I take 5AB divided by 5AB, I would have minus, that would just divide to 1. So this would be factoring out the GCF for that one.